Hey everyone, welcome back to another DxePrep video, and in this video we'll try to find the integral from 0 to pi over 4 of cosine to the fourth of x minus sine to the fourth of x dx. So just immediately looking at the problem, we don't know any clever identities for cosine to the fourth minus sine to the fourth, and we don't really know what we can do. But let's try using the Pythagorean identity, which basically states that sine of x, sine squared of x, plus cosine squared of x equals to 1. And let's see, maybe we can apply some of that in order to solve this. So the first step we're going to do is we're going to try rewriting cosine to the fourth of x and sine to the fourth of x. So cosine to the fourth of x can be rewritten as cosine squared of x times cosine squared of x. And based on this Pythagorean identity, we can substitute in cosine squared of x with 1 minus sine squared of x, because you can just rearrange the terms over here. So that's exactly what we're going to do. And now we can just distribute. And we're going to apply the same idea to sine to the fourth of x. So this sine to the fourth of x can be rewritten as sine squared of x times sine squared of x, which is the same thing as sine squared of x times 1 minus cosine squared of x, because we can just rearrange this over here. And that just leaves us with sine squared of x minus sine squared of x cosine squared of x. And now what we're going to do here is subtract this from that, because that's exactly what the integral is asking us to do. So I'm just going to write this here. Minus, in parentheses, sine squared of x minus sine squared of x cosine squared of x. So first things, we notice that since this becomes positive over here, we can just remove the parentheses over here by making this a minus and making this a plus, and remove the parentheses. And we notice that these two terms cancel out with each other, so we can just cut through them, and that just leaves us with cosine squared of x minus sine squared of x. And we know that's a really famous identity, which is cosine of 2x. So basically all this integral is asking us to do is find the integral of cosine of 2x. So that's exactly what we're going to find. And then we can apply the limits of integration to solve it. Okay, so we can just rewrite this integral as the integral from 0 to pi over 4 of cosine of 2x dx. And that just leaves us with sine of 2x over 2 from pi over 4 to 0. And then we can just simplify that by sine of pi over 2 minus the sine of 0 over 2. And that just leaves us with the sine of pi over 2 is simply 1, so that's just 1/2, minus sine of 0 is just 0, so that's just 1/2, which is our final answer over here. So I hope you guys understood how to solve the integral of the cosine to the fourth of x minus sine to the fourth of x using the Pythagorean identity, and maybe apply to some different cases.